Ladies, gentlemen, Assalamu alaikum. The present work elaboration and characterization of inorganic insulation films from waste glass and alkali silicates was carried out within the Materials, Process and Environment Research Unit in University of Boumerdès. The reuse of waste glass brings environmental and economic benefits as it saves energy, reduces carbon dioxide emissions, decreases the extraction of raw materials, and reduces also the volume of solid waste. Foam glass is one of the thermal and acoustic insulation materials resulting from the recycling of waste glass has the potential for improvement in several aspects due to its attractive insulation property, load capacity, very long lifespan, recyclability or reuse, and the use of waste in its production. It also fits with the concept of economy. In this work, we opted to develop glass films based waste glass and alkali silicates. To elaborate our films, we mixed 1% of filming agent and alkali silicate for 10, 20, 30 and 40%. The resulting powder was well homogenized and pressed at 20 kilonewton per centimeter square. The sample was thermally treated by centering at 850 degrees Celsius for 10 minutes. From the result found for the microstructure of glass films, we see that the addition of sodium silicates increases the size of the pores. The morphology of the glass films shows the presence of communicating pores. The result of differential thermal and thermal gravimetric analysis showed that the thermograms of the sample without and with the sodium silicates represent two endothermic peaks. The first endothermic peak, around 100 degrees Celsius, corresponds to the liberation of physically water. However, the second endothermic peak, around 700 degrees Celsius, corresponds to the decomposition of the carbonate species originating from the filmic agent and alkali silicate, which makes it possible to give our materials a porous structure. The coefficient of thermal conductivity is inversely proportional to the percentage of addition of alkali silicates. Increasing the pore size helps retaining more heat, resulting in low thermal conductivity. The result obtained proved the film's glass have low thermal conductivity between 0.031 and 0.026. The addition of alkali silicates in the manufacture of filmed glass provides excellent thermal insulation properties. To conclude, the result obtained from the microstructure clearly demonstrates that the addition of alkali silicates increases the porosity of the film glass, which gives low thermal conductivity and increases its thermal insulation power. This study has enabled use to expand the use of alkali silicates from traditional use, lingerie, and detergents to high technology manufacture of glass films by using it as a filming agent.